Hello everyone and welcome back again. Today in this session we will have the first example. We will start design concrete with the grade 30. So we design concrete that has 30 megapascal compressive strength at 28 days. And in order to use the Department of Environment method or DOE method, you need to have this information before even starting the calculation or start using the sheet or any things. And we had already discussed this one before here, the principles of mixed design. We need to know the type of cement. We need to know the type and the size, the source of the aggregate, the maximum size of the aggregate. We need to know if there is the degree of the workability required for your concrete, and etc. So this is actually an information that should be collected before starting the mixed design. So this question is giving this information that it will be part of the calculation process. We cannot proceed with the calculation without knowing this information. And you will realize how we can incorporate this information and how this information is required if we need to determine any specific things in the sheet. This is actually the information that is given in the question, and they ask us to determine the mixed proportion for concrete with the grade 30 that can be achieved at 28 days. So we'll start design concrete with a compressive strength at 30 megapascal at 28 days. So let's go through the information that is given, and later we'll see how this information can be part of the calculation process. The characteristics compressive strength 30 megapascal at 28 days. Okay. Defective rate, we need to use a defective rate of 2.5%. And in the following session, we will start to have more details discussing what do we mean by the defective rate in the normal distribution and for the characteristics and determine the main strength. Also, he's telling us that we are using Portland cement of 42.5. This is the type of cement. And we know that the Portland cement come in two different types. We have 42.5 and we have Portland cement of 52.5. So using different Portland cement type will also help us in the calculation sheet, and it will also affect the mixed proportion. So it is essential to know what type of Portland cement that we are using. So he says that we are using Portland cement of 42.5. And the slump required here, it should be in the range between 10 to 30 millimeter. So it is actually lie between in the medium type of workable concrete. So it's not low, it's not high workable, but in this range it means that it is in the medium workable concrete. And also here in the question that the water to cement ratio, the maximum water to cement ratio is 0.55. It means that we should not use water to cement ratio higher than 0.55. And during the calculation, if you came out with water to cement ratio, for example, zero point 0.6, and zero point 0.6 is higher than the maximum, so we should not use this one, and we will use the maximum value that we can use for this question. The minimum cement contents 290 kilogram per cubic meter. Again, during the calculation, if you come out with the water or for the cement contents lower than 290, for example, you come out with 250 kilogram per cubic meter of cement contents, then we should not use this one and should use the minimum value of or minimum contents of the cement. The coarse aggregate, also the source of the coarse aggregate and the type of the coarse aggregate, it's also part of it help us or it is required for during the calculation. So it's telling us that we are using uncrushed coarse aggregate with a maximum size of 20 millimeter. The same goes for the fine aggregate or the sand, and the sand is uncrushed sand. The source of the sand is uncrushed, and here this information also is required that 70% passing through sieve 600 micrometer. And this one actually during the when we determine the sieve analysis test for to determine the grading of the aggregates, and during and in order to get the S-curve grading of the aggregates, we do the sieve analysis test. In the sieve analysis test, we have different sieves, and we put the sand or the aggregate, then we start to shake, and it will go through this sand. This sieve will go with the following sieve, and the following sieve will start to shake. Some will go through the sieve, and some will retain at the top. So a different sieve, we know that we have different sieves with different sizes, and all we need is the sieve that has 600 micrometer, how much passed and how much retained. So we only need the percentage of this sieve, how the percentage of passing through the sieve. And he says that 70%, the percentage, this is the percentage that passing sieve 600 micrometer. This is during the sieve analysis test. And this one also required during the calculation. Other information that also we need is the density of the aggregates, which is 2.5. And the question is already given, and the volume that we need to design is 0.05 cubic meter. So this is actually an information that is required in order to do the DOE methods and in order to calculate the mixed proportion. And what we call it the principles, actually. We call it principles of the mixed design. We cannot proceed, we cannot use the DOE methods without knowing this information. So collecting the information, we have this one in the question or in front of you, then we start using the Department of Environment sheet step by step. At the end of the day, we will come out with the mixed proportion. In the following session, we will start go through the calculation and the stages one by one in order to get the mixed proportion of the mix and design the concrete grade 30 megapascal at 28 days.